students, welcome back to Relief Tutorials. Today we are going to discuss a new chapter, that is pair of linear equation into variable. Okay, so now first we'll understand the meaning. Why? Because in 9th standard we have learned linear equation into variable and we have learned how to represent their graph. Here we are going to learn pair of linear equation into variable. See, what is the standard form? So if you say standard form, standard form is ax plus by plus c is equals to 0. So this is a linear equation. Why? Because here are two variables x and y. So if we talk about variables, so variables are x and y. These two are the variable. Clear? So as there are two variables, it is called equation into variable. Okay. And why it is called linear equation? Because it represents a straight line. When you plot this graph, equation graphically, then you will get a straight line always. So as a result, it is called linear equation into variable. Why we require that we are going to discuss later. So this is standard form, and here A, B, C are constant. Okay, so it represents a straight line, and A, comma, B, comma, C, they belongs to real number. It can be anything. See, A can be 2 by 3 x minus 5y plus root 2 is equals to 0. So here A, this is A, minus 5 is B, and this is C. So this is fraction, so it is a rational number. It is a rational number. Minus 5 is an integer. Root 2 is a rational number. So altogether we can say A, B, C, they may be rational number, they may be integer, they may be irrational number. So all these number altogether they are called real number. So we say A, B, C belongs to R. And you know that A is coefficient of x, B is coefficient of y, and C is a constant. Clear? If you want to mention, we can mention that. Here, so A is coefficient of variable x, and B is coefficient of variable y. C is a constant term. C is a constant term. Clear? And we can say A, comma, B, comma, C belongs to R. Okay, so here now A belongs to real number means 0 is also a real number. So A can be 0, B can be 0, and C can also be a 0. Why? Because A, B, C belongs to real number and 0 is a real number. Okay, so our equation can be this way also. 2x is equals to 8. Or you can say 2x minus 8 is equals to 0. Or you can say 2x minus 5. See, suppose we say 5. Okay. 2x minus 5 equal to 0. So here this is a linear equation into variable. But question arises, sir, how it is a linear equation into variable? Here we have only one variable, x. We don't have other variable, y. Okay. So we don't have term with variable y. Sure. But I can write this equation as 2x plus 0y minus 5 is equals to 0. Now see, we got two variables. So y is not 0, but the coefficient of y is 0. That is b is 0. Why? Because b belongs to R, so b can be 0. Similarly, you can say here, x also can be 0. 5y is equals to 7. So this equation is 5y minus 7 is equals to 0. This is also linear equation into variable. Again question arises, sir, there is only one variable y. There is no other variable x. Okay, so we can write this way, no? 0x plus 5y minus 7 equal to 0. So here a is 0. Ax. So either a can be 0 or b can be 0. Here this is b. Here this is a. So we can say even though if there is one variable, it is termed as linear equation into variable. Here we don't have term with x, so coefficient of x is 0, that is a is 0. Here we don't have term with variable y. See, so it doesn't mean y is equals to 0. coefficient of y is equals to 0. Coefficient of y is b, so b is equals to 0. So if I say 2x equal to 5, then I can say here b is equals to 0. If I say 5y equal to 7, means we don't have a term with variable x, so coefficient of x is a, so here a is equals to 0. So either a is 0 or b is 0. But one question again arises, sir, a and b can be simultaneously equal to 0 at a time. So if that is the case, then our equation starts with 0x plus 0y plus 5 is equals to 0. 0x is 0. 0y is 0 plus 5 equal to 0. So what we will get? 5 is equals to 0. But mathematically this is not viable. 5 can never be equal to 0. So it means either b should be 0 or a should be 0. But a and b simultaneously they are not equal to 0. If a and b are simultaneously equal to 0, then mathematically it will not be viable. So we can say that in linear equation in two variable, either a is 0 or b is 0, but a and b are not simultaneously equal to 0. Clear? So we can say here either a is 0 or b is 0, but a and b are not simultaneously equal to 0. Are not simultaneously equal to 0. See, if you want to represent this statement mathematically, how you represent a and b are not simultaneously equal to 0. So that is a square plus b square is not equal to 0. See, this is possible. This equation is possible when, see, it is a square, so it is always positive. B square, it is also always positive. And sum of two positive numbers is never equal to 0. Right? No. So it means a and b are not, this is possible only if, when it is possible. A square plus b square equal to 0. This is possible when a is 0 and b is 0. See, if a is 0, 0 square, b is equal to 0 square, 0 square plus 0 square is equal to 0. So this condition is possible if and only if a and b both at a time they are equal to 0. But in our case they are not at a time equal to 0. So we will write they are not equal to 0. Don't go in depth, but try to understand. Okay, this statement can be represented mathematically as a square plus b square is not equal to 0. Clear? Now, we know one more thing. It represents a straight line. It represents a straight line. Now, example, you can say 2x minus 5y plus 8 is equals to 0. This is the equation. 2x is equals to 5. Or 2x minus 5 is equals to 0. Here we don't have term with y variable, so its coefficient is 0. That is b is equals to 0. We can say 7y minus 3 plus 3 is equals to 0. This is also linear equation in two variable. Here we don't have variable x. It means its coefficient is 0. That is a is equals to 0. So all these are the example of linear equation into variable. Have you got it, friends? So this theory you have to note it down. Okay, that's quite important. Now I am going to run this. Again, I want to explain you the name of our chapter. You understood that why it is called equation into variable? Why? Because there are two variables. Why it is called linear equation into variable? Because it represents a straight line. Why it says pair of linear equation? See now. Example. If I say x plus y is equals to 7. Where a is 1, b is 1 and c is equals to 7. Clear? In standard form you can write x plus y minus 7 equal to 0. So a is 1, b is 1, c is equals to minus 7. I can write in this order also. Okay. Now question arises. See, in lower standard we have learned 2x is equals to 18. So this is also a linear equation, but in one variable. Here x. You can write 2x plus 0y minus 18 equal to 0. It is also can be converted into linear equation in two variables. So x is equals to And if you represent that x equals to 9 in lower standard, we have learned in 9th standard in 4th chapter, x equals to 9, represent a straight line. You know that x equals to 9. 1, 2, and here it is 9. So this is the line, vertical line. This line is called x is equals to 9. So it is a linear equation. So here you can find a solution directly, okay, if there is one variable. But in this case, how to find the solution? So you will get series of solutions. See, I can say here, okay, 0 plus 7 is equals to 7. So 0 and 7 are the solution. 0, 7. So I can say 0, 7 is one solution. X is 0, y is 7. So this is one solution of this equation. Then I can say 1 plus 6. 1 plus 6 equals to 7. So this is also one solution. Then I get 2 and a 5 is solution. 2, 5. 2 plus 5, 7. Okay, then I can say 3 and 4 is the solution. 3 and 4 is the solution. I can get 3.5 and 3.5. 3.5 plus 3.5, 7. So 3.5, 3.5. Many you will get solutions. 1.1, 5.9. Okay. 5 and 2. So how many such solutions you will obtain of this equation? So there are infinite solutions. I told you, this represents a line. So it represents a line. So all these are solutions are nothing but they are the point of these lines. And you know how many points are there in this line? Infinite point. So the solution is also infinite. Are you understanding, friend, what I am telling? So if you plot this graph, if you plot this, you will get all these points on that line. All these points on that line you will get. So this line has infinite point. And all these points represent these points, all. So line has infinite points, so it has infinite solution. So we will not get a unique solution, we will get an infinite number of solutions. So solution here is nothing but they are the, if you represent it graphically, all the points on the line are its solution. Have you got it? So we will not get a unique solution. So question arises, sir, how to get a unique solution? So for that we require one more equation as there are two variables. So I will take one more equation, that is x minus y is equals to 3. So I got a pair of equation. Similarly here in this case also you will have an infinite solution. Okay. See x minus y equal to 3. So what do you get? 5 minus 2. 5 minus 2, 3. Clear or not? Then I can say 6 minus 3 is equals to 3. 7 minus 4 is equals to 6. All these 5, 2, 6, 3, 7, 4, all these are the solution. So it also has an infinite number of solutions. This also had an infinite number of solutions. But when you plot these two lines, okay, you will get one point. Okay. That is C. If I say here, this here we have 5, 2. Okay. Here also we have 5, 2, C. Both have one point in common. So if you plot this line, you will get one equation. This. Another you will get this way. So here you will get one point common. See, this is x plus y is equals to 7 and this is x minus y is equals to 3. So if you plot these two lines, so there will be one point here. That point is nothing but 5, 2. See, 5x, this is y. 5 plus 2, 7. 5 minus 2, 3. So there is 1 point 5, 2 which lies on both the line. That is x plus y equal to 7 and x minus y equal to 3. So this is called unique solution. That is the solution of this pair of linear equation in two variables. So in short, in order to get a unique solution, you require a pair of lines. And these two lines, if you represent graphically, they will intersect at a point. That point of intersection is a unique solution. Why? Because you see, this is the only point, this P I say. P is the only point which is present on this line as well as on this line. There is no other such point. which lies on both the line except 5, 2. So that is the solution of this both pair of linear equation. So that is a unique solution. So in order to obtain a unique solution, you require a pair of line. As a result, the name of our chapter is pair of linear equation into variable. Just with one equation it is useless. Why? Because we will get infinite solution. So if you want a unique solution, you require one more equation. As a result, always we deal with pair of linear equation. As a result, the name of our chapter is pair of linear equation into variable. Have you got it? See, this 5, 2 is the unique point which is present on both the lines. It is only the one point which lies on both the lines. So that is the unique solution. Have you got it? See, we will discuss in detail later graphically. So this is the name of our chapter, a pair of linear equation into variable. I hope you understand what do you mean by name of our chapter, pair of linear equation into variable. Okay. Now see, we try to plot this graph. See, we will discuss few examples. Why? Because due to limitation of space, the problem which is in your exercise requires a huge space. Why? Because if you plot the point on the graph, axis 1, 2, 3, 4, you take on the axis, you have to go up to 30, 32. So here we don't have that, you can do in your graph paper. So I will deal with some examples. See, we will learn first with example 1. Example 1. We will do many graphs, but example 1, see. See, what is that? See, Akhila went to a fair in a village. She wanted to enjoy rides on the giant wheel and play hoopla. Hoopla is a game in which you throw a ring on the item kept in a stall, and if the ring covers any object completely, you get that object. That is called hoopla. The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride cost ₹3 and a game of hoopla cost ₹4, how would you find out the number of rides she had and how many times she played hoopla, provided she spent ₹12? So here there are two conditions. I will write that condition. See example 1. Number of times she played hoopla. Number of times she played hoopla is half the number of rides she had on giant wheel. This is one condition. And each ride costs ₹3 and a game of hoopla costs ₹4. So giant wheel ₹3 and hoopla ₹4 for one ride, for each ride. And amount spent is equals to ₹20. Okay, so this is the case. Now you have to represent this graphically and you have to find a solution. Okay, this is the case. But before that, see, I want to explain one thing. See, there are pair of linear equation in two variables. See, suppose I say 2x minus 5y plus 3 is equals to 0. Second equation we will take here. 3x minus 7y plus 7y minus 8 is equals to 0. So the standard form of this, there are two equations. So this will be represented as a1x plus b1y plus c1 equal to 0, and this a2x plus b2y plus c2 equal to 0. Why? Because if I say here ax plus by plus c equal to 0, and here also ax plus by plus c equal to 0, for a there are two different values. So as a result, I will take here this, and here I will take this. So here a1 is 2, b1 is minus 5, c1 is equals to 3. Here a2 is 3, b2 is 7, c2 is minus. I got it? So as a result, for these two equations, general form we represent in this manner. Okay, why? Because here the coefficient of x is 2, here the coefficient of x is 3, they are different coefficients. So we can't represent by same symbol a. So we are taking A1, A2, B1, B2, C1, C2. For equation 1, A1, B1, C1. For equation 2, A2, B2, C2. Okay. I hope you understood this. Now, if you represent two lines in a plane, so there are three possibilities. In any plane, if you draw two lines, so there are three possibilities. What are those three possibilities? That two lines intersect each other, or that two lines do not intersect each other. So if lines do not intersect, it means they are parallel. And third condition is that the lines are coincident. So there are three conditions for a two lines lying in a plane. So I can say note here, two lines L1 and L2 lying in a plane alpha. So two conditions, see first, this one, second condition, this, third condition, this. Clear? So two lines, this is plane alpha, plane alpha, plane alpha. This is one line L1, this is another line L2. So L1 and L2. So they intersect. If you draw two lines in any plane, then there are three possibilities. Either they intersect or they do not intersect. If they do not intersect, then they are parallel. L1, L2. Or they are coincident lines. This line is L1. Also this is L2. Same line, coincident. So here they are intersecting lines. Or we can say parallel lines, or we can say coincident lines. If they are intersecting, we get a unique solution. See that we have seen. If they are parallel, means they will never intersect. So you will not get any such point which lies on both the lines. So there is no solution. If they are coincident lines, means all points of line 1 and L2 are common. See, this point belongs to line L1. This point belongs to line L2. This also belongs to L1 and L2. This also L1 and L2. So all these points, they belongs to both the lines, L1 as well as L2. So that is the solution. So how many solutions it has? Infinite solution. Here how many solutions it has? No solution. Here how many solutions it has? Only one unique solution. So we get a unique solution if lines intersect. We get no solution if lines are parallel. Why? Because they will never intersect. And if coincident lines means all the points of both the lines are common. So we get how many solutions? Infinite solution. Clear? So this is the note you have to copy it down. Now we will do this problem and we will represent it graphically. So here you can say unique solution. Intersecting line. So you get unique solution. Unique means one line only one. Unique solution. This is our solution. Unique solution. Parallel lines means no solution. Here you will get infinite solution. Infinite solution. Clear? So two lines L1 and L2 lying in the same plane, so there are three possibilities. Okay? Have you got it? Okay, now I am going to have this. See now, number of times she played hoopla is half the number of rides she had on giant wheel. See, if a giant wheel she had 6 rides, then hoopla is number of times she played hoopla is half. Means if she is going for 6 times in a giant wheel, number of times she played hoopla is half, so that is 3. If she take rides of giant wheel 8 times, then here it will be 4. So here conditions are given, 2 conditions. So first we read first condition. So she played hoopla is half the number of rides she had on giant wheel. But before that, we will take one thing. Let number of rides on giant wheel is equals to x. Let number of times she played hoopla. She played hoopla is equals to y. 2 true variable you have to suppose. Now, she played hoopla is half the number of rides she had on giant wheel. So, how many rides she has on giant wheel? 8. So, hoopla will be half of that, 4, 8 by 2. Here x, so x by 2. So, we got condition here. The first condition, that is called first condition. Number of times she played hoopla. So, she played hoopla is y. Half the number of rides she had on giant wheel. So, half the number of rides she had on giant wheel. The rides she had on giant wheel is x. So, just you convert this language part into symbols. Okay. So, y is equals to, I can say this 2 will go here. 2 will go here. So, 2y is equals to x. Now, 2y you go there. So, x minus 2y is equals to 0. So, we got one equation. Have you got it? This is first condition. Clear? Now, second condition. See, what is second condition? Cost of one giant wheel is 3. 2 giant wheel will be 3 2s are 6. 3 will be 3 3s are 9. 4 will be 3 4s are 12. X, right, is x. So 3x is the total amount spent on ride on giant wheel. For one ride it is 3 rupees. So for x ride how much? 3x. And for one game of hoopla she is paying 4 rupees. So number of times she played hoopla is y. So that will be 4y. So second condition, 3x plus 4y is equals to 1. Total amount spent is 20. So that should be equal to 20. Got it, friends? Cost of one ride on giant wheel is 3. So she had taken x ride. So 3x. Cost of one game of hoopla is 4 rupees. She had played y game. So 4y. So 3x plus 4y should be equal to 20. Why? Because total amount spent is 20. So this is equation 1. This is equation 2. So based on the condition given, you have to obtain two equations. Now you have to plot these two equations graphically. Clear? So now we'll see here. See. There is certain limitation, friends. Now first, x minus 2y equal to 0. So you will obtain graphically. I will draw the graph here. Yes. See first. X minus 2y equal to 0. Okay. So 2y, x equals to 2. I can say generally 2y. This 2y is equals to x. So y is equals to x by 2. Always you obtain the value of y. So I will write here. Now I make a x and y. If I take x 0, x 0. So 0 upon 2 is 0. So y is also 0. I will take x2. x2. So 2 upon 2, 1. Clear? Again you can take x4 out. So 4 by 2, 2. So these are the plot you obtain from this point. Now we have 3x plus 4y equal to 12. Now we will see 3x plus 4y equal to 20. So 4y is equals to 20 minus 3x. Clear, friends? Obtain the value of y. You know that we have done graph. Now y is equals to 20 minus 3x upon 4. So now I will write here x and y. Clear? Now I will suppose x. X is 0. X 0 is 20 minus 3 into 0. 3 into 0 is 0 upon 4. So that is 20 by 4. So that is equals to 5. Got it? Now I will take 3, 4. 3, 4. So 3 4s are 20 minus. X is 4. 3 4s are 12. 20 minus 12 upon 4. 20 minus 12, 8 upon 4. 8 upon 4 is 2. So that is equals to. Enough 2 points. Clear? So 2 points is sufficient. Now you got point. Now you plot this point. Clear? So this is x-axis and this is y-axis. Sorry, this is x-axis, this is y-axis. Now you know it is 0, here you will take, see on x we have maximum 4, x is 1, 2, 3, 4, 5. We don't have minus, I am writing just here minus 1. Then on y you are having maximum 5. So I am writing here 1, 2, 3, 4, 5. Here you will write minus 1, minus 1. Clear? So this is a graph. Now we will plot the point. Clear? See, very simple. First we will plot this. 0, 0, origin. This is the point. See, don't at a time you do. First you plot this point, you draw the line, then you go for this point and draw the line. Otherwise, all this point will get messed. 2 and 1, x coordinate 2, y is 1. So here you will get 2, 1. 2, 1. Here. And x4, y2. x4, y2. This point you got. Now we will draw a line. Clear? See, this is circle limitation. I told you. 2. See, this is the line. This is the line. This line is x minus 2y equal to 0. So x minus 2y is equal to 0. Clear? Okay, this line. Then we will plot the point of this line. Okay? After drawing the line. Now x0, y5. So x coordinate is 0. Point is on y-axis. Here you go. X coordinate is 0. So point is on y-axis. If y coordinate will be 0, then point is on x-axis. Clear? Now 4, 2. This is 4 and this is 2. This is the point. 4, 2. Now we will draw the line. This is line. Which line it is? 3x plus 4y is equals to 20. Now both these lines are intersecting lines. So if they intersect, then you get a unique solution. Which is that solution? See, this is the point. And this point is what? You know, this point is 4, 2. See, this is the point. 4, 2. So here also we have 4, 2, here also we have 4, 2. This 4, 2 is a point which lies on both the lines. So that is the solution. So this is x, this is y. So value of x is 4, value of y is 2. So 4 rides on wheel and 2 game of hoopla. The 4 rides on wheel and for wheels is 3 rupees. So 4 3s are 12 rupees you will get here, 12. And 4 rupees is for hoopla. So 2 games, 4 2s are 8. So 12 plus 8, 20. So total amount spent is 20. That is our solution. So this is the graphical method to obtain the solution. Have you got it, friends? Okay. So in this way you can plot the graph. So you will be having two conditions. Based on that two conditions, you will obtain two equations. Then you will plot a graph. Okay, and wherever the line intersects, that is the solution. So here at last you will write here, okay, number of rides on wheel, number of rides on wheel, number of rides on wheel is equals to x. X is 4. And number of hoopla game, number of games of hoopla is equals to 2. Have you got it, friends? I hope you enjoyed this. Okay. Now, so this is the case I am going to repeat. This is the example 1. I am going to write the name of our chapter also. See, now we discuss example 2. Example 2. See example 2. What is that example 2? We will see this. Romila went to a stationery shop and purchased 2 pencil and 3 eraser for ₹9. So 2 pencil and 3 eraser for ₹9. Okay, Ramila. Her friend Sonali showed the same new variety of pencil and eraser with Romila, and she also brought 4 pencil and 6 eraser. So this is Romila. Now her friend, that is Sonali. Sonali purchased 4 pencil and 6 eraser for ₹18. Represent this situation graphically. So you have to represent this graphically. So first, what you will say, 2 things are there, pencil and eraser. So cost of 1 pencil is equals to ₹X. Cost of 1 eraser equal to ₹Y. Now first condition. See, first condition you see, cost of 1 pencil is X rupees. So cost of 2 pencil will be 2X. Cost of 1 eraser is Y rupees. So 3 eraser will be 3Y. And the total cost is ₹9. So this you got first condition, first equation. Got it, friends? Now second condition. Sonali purchased 4 pencils. So cost of 1 pencil is X. So 4 pencil will be 4X. And 6 eraser. So 1 eraser is Y. So 6 eraser will be 6Y. And total cost is equals to ₹18. So this you got second condition. Have you got it, friends? Now, see, if I give a pair of equation and just mere by observation, looking at the equation, will you be able to say that whether those 2 equations represent intersecting lines, parallel lines, or coincident lines? Till now it was not possible, but now it is possible. Just mere by observation. Come on, now look at these 2 equations. Just look at these 2 equations. 2x plus 3y equal to 9. This is equation 1. Second equation you see 4x plus 6y is equals to 18. I can say what type of equations they are. They are coincident lines. Sir, how? See, you can take common or you can divide each term by 2. That is taking common or dividing the term is same. Now okay, come on, you take 2 common. So 2 common, so you get 2x plus 3y is equals to 18. Or you can say 2x plus 3y is equals to, this 2 multiplication goes here division, 18 by 2, what will you get? 9. See, this is equation 2. 2x plus 3y equal to 9, 2x plus 3y equal to 9. Both represent the same equation. So if you plot them graphically, you will get the same line. So it means those 2 lines coincident, they are the same line. So you will get infinite solution. So mere by looking at the equation, you can say, see nothing, 2x, so here we got 4x, here 3y, the double, 6y, 9, double, 18, 2 2 take common. See, taking 2 common or dividing each term by 2, both are same. See, 4x divided by 2, you get 2x. 6y divided by 2, you will get 3y. 18 divided by 2, you get 9. So now onwards, we will not take common, but we will divide each term. Both are same. So now both equations are same equation. You draw this equation graphically, you will get a line. This is also same, so you will get the same line. So they are coincident lines. So all these points, they belongs to both the lines. So it is a solution. So how many solutions? Infinite solution. You are learning something new. See, always you should try to think in that way. So what new thing today I am going to learn? So that will create what we can say one type of curiosity in you. So this is the case. Okay. So I am going to run this. Slowly you will come to understand. Now both we will represent graphically. First equation 2x plus 3y equal to 9. So you will say here 3y is equals to 9 minus 2x. Y is equals to 9 minus 2x upon 3. There is a tradition. So always we find y, x and y. Now you suppose x. So you suppose x 0. X is 0. 2 into 0, 0. So 9 upon 3, you will get 3. Clear, friends? Okay. Now what you will suppose? Come on, tell me. If you suppose minus 1 by 3, that will be very difficult to prove. Now you suppose from your way, this number. See, if I suppose 4, 2 4s are 8, 9 minus 8, 1 by 3. So 1 by 3 will be difficult to prove. So then you will suppose 3. 2 3s are 6. 9 minus 6. 9 minus 6 upon 3. 9 minus 6 is 3. 3 upon 3. You will get it? 1. Clear, friends? So this is the case for first equation. Now for second equation. 4x plus 6y equal to 18. 6y is equals to 18 minus 4x. No need of this, but even though. Y is equals to 18 minus 4x upon 6. X, y. X, 0. X 0. 4 into 0, 0. 18 upon 6. 18 upon 6 is 3. Clear, friends? Now 3 you suppose. See, 3. 4 3s are 12. So 18 minus 4 into 3, 12 by 6. 18 minus 12, 6 by 6. So you get 1. Same point, you get nothing else. Same variable you suppose. Okay, now we'll draw the graph. Okay, this is y-axis, this is x-axis. X-axis. Now I take here, see, 1, 2, 3, 4. You just look here, you come to 0, 3, x. So maximum 3 we require on x-axis. On y-axis we also require 3. So here also 1, 2, 3, 1, 2, 3. Again 1 and 4. That's all. All are positive. First coordinate is sufficient. Now x coordinate is 0. Point is on y-axis. 0, 3. See, you got it? X coordinate is 0. Point is on y-axis. So this is the point. x3, y1. x3, y1. So this is the point. Here also same 0, 3, 3, 1. Same point you will get. Draw the line. So this is the graphical representation. So all the points on the line. all the points on these lines. Here they are the solutions, so infinite solution. So this is line both same line L1 and L2. This is L1 and L2. So this is L1 and this is also L2. Coincident lines. Have you got it? Clear? So I am going to rub this example 2. Now we will discuss last example, that is example 3. See, we are discussing example 3. See what we have. Two rails are represented by equation x plus 2y minus 4 equal to 0 and 2x plus 4y minus 12 equal to 0. Represent this situation graphically. So two rails, and you know that rails never meet, so naturally they will represent the parallel lines. But just mere by looking at the equation you should know. See, I will explain how you will come to know that. See, we have x plus 2y minus 4 equal to 0, this is equation 1. Second is 2x plus 4y minus 12 equal to 0. You see, I will divide by 2, so you will get here x plus 2y minus 6 equal to 0. So this I can write x plus 2y is equals to 6. This I can write x plus 2y is equals to 4. The case will be same. RHS are different. So if LHS is same and RHS are different, they represent parallel. See, we plot graphically. Now first equation, x plus 2y minus 4 equal to 0. So x plus 2y is equals to 4. Okay. So x plus 2y is equals to 4. 2y is equals to 4 minus x. Y is equals to 4 minus x by 2. Now, just 2 point is sufficient to draw a line. Now x I will take 4 or 0, come on. X is 0. 4 minus 0, 4. 4 upon 2, 2. Now x I will take 4. 4 minus 4, 0. 0 upon 2 is 0. Enough these 2 points. Second equation, 2x plus 4y minus 12. So I can write equal to 12. So 4y is equals to 12 minus 2x. Here, so I can write y is equals to 12 minus 2x upon 4. xy, I take x0, 2 into 0, 0, 12 by 4, 3. I take x6. See, 2 6 are 12, 12 minus 12, 0. So in such a way I have taken one coordinate is 0. Okay, never mind. Just we'll draw this, we'll represent graphically. See, 0 4 0 6. So next coordinate we want up to 6. So this is 5. This is 6. Here, here 2 0 3 0. Enough. All are positive in first quadrant. Now plot the graph. Okay. Now first, this x coordinate is 0. Remember this. I have explained you 9th standard very well. X coordinate is 0. So point is on y axis. Y axis, that is at 2. So this is the point. 0, now this point. Which coordinate is 0? Y. Y coordinate is 0. Point is on x axis at 4. X axis at 4. So this line we got. We'll draw the line. So this is the line. Which line it is? X plus 2y minus 4. X plus 2y minus 4 is equals to 0. So this completed, over. Now we plot this. X coordinate is 0. Point is on y axis at 3. Y axis at 3. This is the point. Now here y coordinate is 0. Point is on x axis at 6. This is the point. So this is the line. Which line it is? 2x plus 4y minus 2l equal to 0. You look at both the line. Look at both the line. So these two lines are parallel. So we have seen the graph of two intersecting lines, coincident lines and parallel lines. Clear? Now in next lecture, we will take the examples of all these three graphs which we have mentioned. Clear? See now. See, I am going to rub this. See, in our third problem, this was third problem. Which were the two equations? One was x plus 2y minus 4 equal to 0 and 2x plus 4y minus 2l is equals to 0. Question number 3. Lines were parallel. I am just keeping the diagram. Lines were parallel. In the previous case, this is example 3. Now in example 2, what we obtained? If you know that. In example 2, two lines were obtained with 2x plus 3y is equals to 9 and 4x plus 6y is equals to 18. In this case, what graph you got? In this case, graph was, you know that, is L1 and L2. This was the case. Here in this case, you know, what was our, say, this was the case, parallel lines. Clear? In first example, what were the equation? You know, in first example, the equation were x minus 2y is equals to 0 and 3x plus 4y is equals to 20. And here, you know, our graph was, you got to this was the case in first case. Clear? And second, you know that we have drawn the graph. You just refer what was the graph. So graph was this way, you know that. This was the graph. L1 and L2. This was L1, this was L2. Here L1 and L2. Clear? This was our condition. First case we got intersecting line, here we got coincident line, and here we got two parallel lines, and these are their equation. Now we will see the relationship in next lecture. So till now you learn the theory of linear equation in two variable, and you draw these three graphs in your graph paper. Okay? The rest of the thing I will explain in the next lecture. Hope you have enjoyed the lecture. Even though if you have any query, please feel free to call me. Thank you very much. Enjoy your day.